Hello, 7th period honors algebra students. Mr. Lawrence here, and we're going to do a little test review because you have a test tomorrow. Now, the important thing is you might want to have the substitute or perhaps the president, Michael McFadden, standing close by to the computer so they can pause it often. You know, maybe bring a notebook up or something, Michael, pull a desk by it. Can't use the airliner because I'm using a different computer. Anyway, let's get down to it. What I'm going to do is I went into digits. You know, I assigned you a practice homework. The end of chapter practice and review for chapter 4 in digits, not Excel, digits. And I'm going to do some of the problems, and then you can go and do some of those again. You can check for similar exercise, or you can also focus on the ones that we didn't get to. So let's get down to this. Number 1, it says y equals negative 2x plus 7. Now you do not know how to graph this any other way except for using an input-output table. So I'm going to make an input-output table, and I'm going to suggest that your input be negative 1, 0, and 2. All right, I'd like you to pause the video now. When the class is ready, you can unpause it and see my solution. Here comes my solution. So I'm going to plug these three numbers in for x into the equation. If you can't read it, I'll rewrite it. Y equals negative 2x plus 7. All right, so if I plug 0 in there, I get 7. If I put negative 1 in, I get 9. And if I put 2 in, I'm going to get positive 3. Okay, you should have gotten those for those inputs. So I'm going to go ahead and erase this because it's going to be in my way in a second. But I'm going to graph them now. So I come over here to this line tool and I do 2, 1, 2, 3. I also need 0, 7. So I go over to where 0 and 7 meet up, and there we go. Now, if I'm right, negative 1 should be up at 9. So let's see here. Negative 1 looks like it's about there. And look at that. It's at 9, isn't it? Yeah. All right. So I'm going to save it. There's a picture. I will check my answer, and yippee skippy for me. All right. So I am going to move on to question number 4 now. And hopefully we don't have any technical glitches. All right. Go away. I told you to go away. You're not listening. All right. Very good. So let's see here. We have y equals x squared plus 3. All right, we should know what kind of function it is. We should know it's quadratic, which means it's going to be a parabola. Well, I only see 3 parabolas over here. We definitely can rule out this one. Right? Okay. We might want to blow some of these up here. Let's see. Ooh, there we go. Interesting. I wonder what that point is there. That looks kind of like the point. Let's see, that would be the origin, so that would be the point 0. It looks like it went up 1, that would be 2. So look at maybe between 1 and 2, or excuse me. Oh, it's going up 10. So let's see, 1, 2, 3, 4, 5. Oh, so it's going up by 2s. So this is 2, 4, 6, 8, 10. So if this is 2 and that's 4, this must be 3. That's the point 0, 3. All right. I'm going to erase this. I'm going to remember that 0, 3. Okay. Close that. Close. I say close. You're not listening again. Okay. This one here has the point 0, negative 3, right? 0, negative 3. And then this one here looks like this vertex is at the origin, 0, 0. So I have 3 possibilities. I have a parabola with an origin at 0, 3. I have a parabola with an origin at a vertex at 0, 0, not an origin, excuse me. And then I have a parabola with a vertex at 0, negative 3. So what I'm going to do is I'm going to do an input-output table. But all I care about in this case is what happens at 0. Because the 3 parabolas, that's a defining characteristic. So I'm going to put 0 in for x squared, and I'm going to get 3 out. The correct answer is going to be the parabola that has a vertex at 0, 3, which was A. And so I shall check my answer, and look at that. Look at how smart I am. All right, I want to do number 5. And before I do that, I got to get rid of all this. All right, very good. Okay, the price of pizza is $6.45 plus 90 cents for each of the T toppings on the pizza. sounds like an equation to me. It sounds like the price is going to be $6.45 plus 90 cents for each topping T. There's my equation. Okay, write a function rule that represents the situation. Looks like I just did that. So I'm going to come in here and I'm going to go $6.45. Notice I did not put the dollar sign. 0.90 T. And I'm fantastic. I know because Digit told me I was. All right, very good. All right, hopefully, Asim, you're not sleeping. Asim, wake up! Okay, next, I want to jump to number 7. And so number 7 says, write a function rule for the area of a rectangle. A rectangle what? A rectangle? Guess I better draw a rectangle. Okay. All right. And I know that to get the area of a rectangle, I do length times width, right? Except this says, write a function rule for the area of a rectangle whose length is 8 feet more than the width. Well, to figure out the length, I got to know the width. So the width is W. This is 8 more, so this would be W plus 8. So to get the area, I'm going to need to do W plus 8 times W. All right, so I'm going to put this in here, and I'm going to go the quantity of W plus 8 times W, and I will check, and it liked it. It told me I was excellent. All right, so now the area of the rectangle when the width is 8 feet is, well, if the width is 8 feet, right, then the length is 16 feet. Well, then the area is 16 times 8. And I don't want to do the long multiplication. I'm going to double this, double it again. So 16 doubled is 32. Doubled again is 64, and double again is 128. 16 times 8 must be 128. Let's see, feet squared. Oh, I did a good job. Excellent. All right, so let me get rid of all this, and we are going to jump down to number 8. Not a very far jump, if you ask me. We've got a mapping here. Now, if there's any way you can enlarge this, I'm going to try. I don't know if you can, but hopefully that's better. If you need to get closer, you have the pause the video. Okay, the domain here goes 5 to 4 and 5 to 2, 3 to 5 and 3 to 8, 8 to 6 and 1 to 10. Okay, the domain on this one goes 4 to 5, 2 to 5, 5 to 3, 8 to 3, 6 to 8, 10 to 1. And it looks like C goes 5 to 4, 3 to 5, 3 to 8, 8 to 6, 1 to 10, 5 to 2. Now, which of these diagram represents the relation? Okay, so use a mapping diagram to determine where the relation is a function. Okay, so where's 5 going? Only to 4. Is there any other 5s? Yep, 5's going to 2. Remember, the domain is like the people. So 5, I don't know, let's use Nick Olson. Nick, and the range, the Y values are like restaurants. Since 5 is going to 4, Nick's going to Burger King. And then over here, 5 is also going to 2, which means Nick is trying to go to McDonald's at the same time. This is not functional. Nick can't do that. He can't go to 2 different places at the same time. So this is only a relation. So we have to come down here and see which one represents it. Well, 5 is going to 4 and 2. Here, 5 is only going to 3. And in this one, 5 is only going to 4. Oh, and it's going to 2 there. Oh, that's tricky. It's tricky how they did that. All right, let's see. 3 is supposed to go to 5 and 8. So 3 is going to 5 and 8. 3 is going to 5, and 3 is going to 8. 8's going to 6. 8's going to 6. 1's going to 10, and 1 is going to 10. Which one do we pick? It's either got to be A or C. Well, we don't want to list a member of the domain more than once. Remember we did unions and intersections? We didn't list things multiple times. So why is it my final check? Very interesting. All right, well, anyway, I did a good job. Is the relation a function? No. Why not? Because 5 is going to 2 different places at the same time. All right. Oh, I'm doing such a good job getting so ready for this test. Okay, let's drop down here to number 11. I've got them written down. I had to check. Okay, it gives the range and function for the given domain, range of the function. So f of x is 2x plus 5, right? So let's see here. We've got 2x plus 5. And it looks like our domain is -2, -1, 0, 1, and 2. All right. Well, to get the range, the outputs, I'm going to put these numbers, input these numbers in for x. So like I'm going to do f of -2, which is going to be 2 times -2 plus 5. Well, that's going to be 1. All right, when I put -1 in there, I'm going to get 3. When I put 0 in, I'm going to get 5. When I put 1 in there, I'm going to get 7, and then, of course, 9. All right, so my range is 1, 3, 5, 7, 9. It looks like my choice is C. I'm going to check the answer. Good job. All right, moving right along. Pause the video at any time you need to. You should actually be pausing before we try to do some of these. All right, 12. A car can travel 31 miles for each gallon of gasoline. The function d of x equals 31x. So let me write that a little bit larger. D of x equals 31x. That represents the distance in miles, d of x, that the car can travel with x gallons of gasoline. The car's fuel tank holds 16 gallons. Important information there. The domain. Well, what's the maximum the fuel tank can be? Well, the max is going to be 16. What's the minimum? Well, if you run out of gas, how much gas is in the tank? 0. 0. There's our domain right there. That should be it. So it should be D. Dun, da, da, da. Oh, I'm excellent again. Okay. Now it says choose the correct range. Oh, choose the correct range. Here I thought I was done. So we're going to make a table 0 and 16. We're going to figure out how far the car goes on 0 miles and how far it goes on 16 miles. And then we'll know how far we can go between what and what miles. So obviously it's going to be between 0 for 0, right? And then I'm going to do 31 times 16, or 31 times 16, and I like to do it this way, 6, 18, 19, and I'm going to carry that 1, and I'm going to get a 4, 496. So I'm thinking the car can go between 0 and 496 miles. All right, so let's see if I'm right. Uh-oh, danger, Will Robinson. Oh, I checked the wrong one. Sorry about that. I had a panic. Silly me. There. What? What am I doing? Oh, Mr. Lawrence, you're not taking your time. Yeah, I have the right work here, but because I didn't take my time, I didn't do it right. Okay, please let that be a lesson to you. So I'm going to continue. And what is going on here? I'm very confused. I'm confused. All right, let's... Okay, choose the correct graph below. Well, if this is the correct range, the range has to go from 0 to 496. Now remember, the domain went from 0 to 16. So if I look on here, this graph is starting at 0. And then 1, 2, 3, 4. So these are going to be 5s. 5, 10, 15. So right there. I don't know about that. Let's see. 1, 2, 3, 4. Is that going 150? Yeah, this would be 300. And so that'll be 450. That's a possibility there. It looks like it could be 16, 450. Let's try this one. It's going from 0, 0. Ooh, I like that one. Yeah, because this one goes beyond 16 miles, doesn't it? I don't think this can be the right one. I like the way it looked. What's wrong with this one? Well, this one's not starting at 0 miles. If there's no gas in the tank, I can't do that one, so that one's not right. This one is starting at 0, 0, but when x is 16, I'm only not even going 300 miles. My work before showed me I was going well over 400 miles. I believe the correct answer is going to have to be C. Hopefully I didn't do anything silly, and I didn't. I got a nice work comment. Oh boy, I'm such a good boy. All right, so let's see here. Let's move on to 15. 15. All right, a car can travel 27 miles. Oh, what's this? Oh, I have to go back and do it again. Sorry. Silly me. No, am I on 15? Okay, a car can travel 27 miles for each gas of gasoline. Each gallon of gasoline, excuse me. There's my function. Okay. The domain, well, how many gallons? What's the minimum number of gallons? 0. And the maximum number of gallons, the maximum number of gallons would be 11. Now let's make sure I pick the right one this time. Looks like it's going to be C. And there we go. All right, so choose the correct range. Well, it's going to go from 0, and then I need 27 times 11, which I think is 297. So it looks like B is going to be my correct answer there. All right, good job. And I think we're going to do a graphing one here. Okay, so remember the range was 0 to 297. So, and it was there at 11 miles. So this number here is 300. Okay, right? And 300. Okay, so let's go through and critique these. I don't like this one because the range is not long enough. It's not even going anywhere near 300, so that one can't be right. This is a possibility. I'm going to put a question mark there. This one I don't like because the gallons goes way past 11. 10 is here, right? This is going to 20 gallons. The car doesn't hold 20 gallons. Now, this one here looks like it might be going a little bit too far, and it doesn't start at 0. So I am betting that the correct answer is B. And let's check the answer. There we go. Okay, almost done here. We're going to do 16, 16, 16, 16, go. All right, the bids in an online auction are represented by the arithmetic sequence shown below. Remember, that just means it's a linear sequence. Write an explicit formula to represent the bids as an arithmetic sequence. Arithmetic sequence, write an explicit formula. So explicit formula is where I go A of n, and that's going to equal A sub A of 1 plus or minus n minus 1 times D. All right, now in this one, A of 1 is 186. D looks like it is going up. It's going up 11. Yeah, I think it's going up 11. So there is my explicit formula. Now, because it's specifically said, oh wait, well, I guess let me do this in pieces. So I'm going to need 186 plus, because it's going up, I don't want the minus there, quantity of n minus 1 times 11. All right, good job. Now, I need to know A of 10. Well, this is the easy part. And this is, remember I said the recursive formula doesn't make a whole lot of sense to me to do it that way, but the explicit formula, it does. Because watch this. I'm going to get 186 plus 9. How did I get 9? Because n is 10. And that's 11. So I'm going to have 186 plus 99. Well, 186 plus 9 plus 100 would be 286. So this must be 285. So let me go here and put a 285 in. And there you go. All right. So get rid of that. And then finally, I want to do number 17, right? Number 17. Okay, so write an explicit formula for the recursive formula. So explicit formula again is a of n equals a of 1 plus or minus quantity of n minus 1 times d. So in this problem, a of 1 is 7 1/10. Okay, let's see here. Looks like d is positive, so we're going to use plus n minus 1, and d looks like it's 4 9/10, and that should be one of my choices over there. Seven 1/10. There it is. Choice D. And it loved it. All right. That is the video. You can go and do some practice. If there's a lot of time left in class, I guess you can do a little studying. Unfortunately, I don't have the computers. Mrs. Young does. Anyway, that's it for the video. Mr. Lawrence signing off. Good luck on your test tomorrow, everybody.